I'll just start with this so that they can see at home what we're doing, 8.2, and here we go. So first group with the A. The first thing I could say is you could easily name your restrictions without having to do any work. So could somebody from group A tell me what you put for your restriction? Any of the, I think there was like 4 of you. What did you get? Well, first I want the restriction. What can... Okay, wait, before you give me all that, though, I want the restrictions. You want to name those right away so that we don't forget anything. So your restrictions would have been your vertical asymptotes and your holes before we got to chapter 8. So where do we say the restrictions came from again? From the denominator. So do you see a variable right there where I'm pointing? So what do you think C cannot be? Good. So C cannot be 0. What about this? What do you think? Okay, so A cannot be 0 and B cannot be 0. So I want to so state my restriction so I don't forget about it because it goes even with the original problem. Now I can do what you said. Let's start canceling. Did you say the A's cancel? Okay. A's cancel. B. Okay. So you have a b to the 2 over a b to the 1. From Algebra 1 days, like base division, you subtract your powers. So that leaves you with a b to the 1 in the numerator, and that one goes. Same with the c. Awesome. So we'll cancel that, and we'll put a c to the 1. More? Okay, so 2 goes into itself once and into 4 twice. Perfect. 3 goes into itself once and into 27 9 times. Now at this point, I'm just going to write what's left there. So I see a 1bc over 2 times 9. There's nothing else I can do. Stop, I'm done. Question. Anybody on the first one? Anyone? So that was a little bit easier because they were all monomials. Okay. The B group. Step 1, we had to do some factoring right here before you did anything. Okay, so 5 and a quantity x minus 3. Awesome. Okay, that's going to help me name my restrictions. I have 2 restrictions. X cannot be, it's not 5, 3, and 0. Good. 5 is just the number 5. It didn't have a variable with it or anything like that, so you don't touch it. But this x squared, when you said x squared equal to 0, wouldn't that give you an x is 0? So now that I have my restrictions listed out, does anything cancel? Yes. What goes? X minus 3 with x minus 3. Okay. Anything else? 3x goes into 9x squared how many times? 3x. Okay. That looks like, okay, ooh, what's left up on top? Everything went. 1. So when you guys are tutoring, some of you will be, that's something where the person you're tutoring might want to put a 0 because there was nothing there. But actually when you're going 3x goes into itself once, there's really a 1 taken for granted there. So be careful with that. In the denominator, I'm left with a 5 times 3x or 15x. Done. Question? Anybody? Okay. Group C, we had to factor and factor before we could name the restrictions. Yes? Okay, good. X minus 3, x minus 1. Uh-huh. Perfect. Okay, so I totally factored the denominator. After I do that, I like to name my restrictions so I don't forget. Wait, it's their problem. Unless you guys didn't have C, did you? Okay. So x cannot be, okay? Okay? Perfect. Everybody okay so far? Okay, let me change colors for canceling. Okay, what goes? x plus 5s, okay. Awesome. Is that it? So what are you left with in the numerator, please? 1, awesome. Denominator is 4 times quantity x minus 1. If you wanted to distribute, you can. You absolutely do not have to for me. When you're checking answers online, they tend to distribute and FOIL and do all that stuff. I am happy with this answer, okay? So this is my final simplify. This is my final name the restriction. Correct. The reason why I said this is also okay is if you make a mistake along the way when you start putting things together, I don't want you to miss something after you've already got the new part, okay? Like because you're messing up with your foiling from algebra. Okay, is there somebody brave in this big group of Group D that wants to start me? Group D. Okay. Perfect. So we're going to factor out a 7. We have 7 times quantity x minus 1 over 3x squared. And then I'll rewrite the x plus 5 because we don't have to touch it. And then, good. Let me just write on the side here. So when we factored out the 9 from this, you would have had an x squared minus 1 there, which in turn you would have factored a little bit more. Okay, next part. In this numerator, x and x, is it a 2 and 3 or a 6 and a 1? Awesome. And then the denominator is a double factoring again because you can factor out the awesome. And so that would have left us with an x squared plus 6x plus 5, which is x plus 1. Awesome. Question on that? Are you just resting your hand? Yeah. Okay. Anybody so far? Let's name restrictions. What x cannot be. X cannot be 0. Good. And negative 5? Good. Question. Anybody? Everybody? Okay. I forgot to write the 1. Oh, okay. Now, let's change color so you can see the canceling. What goes? Okay. X minus 1 with x minus 1. Okay, so let me just discuss this with you. Definitely the x plus 1. There's an x plus 1 in the numerator. There's 2 of them down below. Does it matter which one down below I cancel it with? Absolutely not. It is totally your choice. I'm going to do this because I feel like it. Now, what else goes? Anything else? Very good. Anything else? Nope. So let's write 7 times quantity x minus 6 over 3 times 9 is 27. X to the 2, x to the 1 is x to the 3 times quantity x plus 1. So this would be my simplified answer, and down below are my restrictions. Anybody not good? Okay, so that's multiplication. The only added step that we're going to add in with division is the value that follows the division sign. What are you going to do to it? Flip it. Okay? Everything else is the same kind of thing. So if you can multiply, you can divide. When you do division, you're going to have to name your restrictions before you flip your value as well as after, because that way you're taking care of the whole problem. I'm going to do it in 1 sec. I'm going to change the frame. Yeah, there was one right here. From when we factored x squared minus 1, remember? So that was x plus 1, x minus 1. And then when we factored this right here, which after the x, it was an x squared plus 6x plus 5, we had an x plus 5, x plus 1. So my question was, there were 2 of these down below, but only 1 on top. Yeah, and in the other classes, people wanted to know how come I canceled what? You know, like, did it matter? Why didn't I do that one kind of thing? If I canceled this one, then I couldn't have canceled this one. It doesn't matter which one. So I've seen people put the two of them together and write quantity x plus 1 squared and then go back and cancel a set of them. Correct. You cannot. Okay, on page 618, I'm not reading this to you, but this is the connect with third grade division and then dividing in algebra with the variables so that you can read through, or if you're helping somebody and they're iffy with the rules of division, you can go, don't you remember when, and show them how they did it when you were dividing with your fractions when you were younger, and now the extra step we're adding in besides the restriction. In addition to that, on that page, there's this great example with Ranger. So check out Ranger's problem. I'm not going to do the whole thing with you. I just want to chat what I noticed. First thing they did was they took anything that could factor and they factored it. That was their step one. So they took the x squared minus 16 and wrote x plus 4x minus 4. The first term, he factored out a 4x. In the denominator of the second term, they wrote x minus 1, x plus 6. Then these last two terms, the last term numerator, denominator, they factored. Then, once they did that, the value that followed the division sign right here, they took and they flipped it. And then the value that followed this division sign, they took it and they flipped it. So that's what you see on the next step. And then they start to cancel. See how they put everything back together again in his final answer? I don't expect that of you. So I would have been fine with an answer like this. So earlier today, somebody asks, can we cancel the x plus 6 with the x minus 6? And you would tell me what? No. Those binomials have to be identical in order to do that. Question? Okay. Yes? Oh, so they took this. Do you see where I'm pointing? And see how x plus 4x minus 4 was in the numerator? Now it's in the denominator. And then they took the x minus 1, x plus 6 that was in the denominator and moved it up top. And then they did the same thing with the next set of values. Now, your restrictions come from the denominator before and after the flip. So let's talk about some restrictions. So this was before the flip up on top. So x cannot be, tell me some values it couldn't be. 0, good. 1, -6, -4, and 3. Then after you flipped it, all these that were in the numerator ended up down here in the denominator. So was there anything extra we can add to our list? Yeah, there is. What else? 4 and 6. Good. And of course, you can write plus minus instead of writing it separate. So make sure you do both the before and the after. So that was just a really good example there for you where they didn't just give you the example of the easiest problem, so you could have that when you're working through. Okay, so we're not doing A. Everybody better be able to do that. B. So I need a volunteer. I'm going to want different volunteers to be the voice of B, C, and D. Okay. Daniel, are you going to do B? Okay. Tell me what to do. Give me my steps, like as far as factoring first. Okay. So I have 7x squared. You're going to take out a 3. Now, if you are a mental math person, you can save yourself a lot of writing strokes. When I factor out a 3 from 3x squared minus 27, would you agree I have x squared minus 9? So then you could go right to that x plus 3, x minus 3, and not waste a whole line of writing. What else can you do? Anything? Good. Okay, so with what I have so far, I'm going to name my restriction. So I see a restriction of x cannot be what? Awesome. Everybody with me so far? Which piece are you flipping? Good. The second one. So if I flip the second one, that was because I was wrapped up. That's why I did the spin. Your 3 times quantity x minus 3 goes to the numerator, and the 4x squared in the denominator. Do you agree? So say it again, I'm sorry. Yeah, we're going to add to our restriction. So now we have a 0, and that's the only thing extra.
Why did you decide to flip the second?
Wasn't it a division problem? So for division, you always flip the value that follows the division sign and make it multiplication. It's whatever follows it. So like in a second, we're going to do one of these. Oh, there's a division and a division. So I'd have to flip this and this, whatever follows the division sign. That's why you don't hear me say just the second one, because I don't want you to get confused when there's a third one. Now, is everybody okay? Okay, so I'm going to cancel out my x minus 3's also. And my 3, x squareds. Is that it? So you're left with a 7 in the numerator, 4 times quantity x plus 3 in the denominator. If it makes you happy, you can distribute it, but you absolutely do not have to. Good job. Question on that, anybody? Anyone? No? Okay. We're going to leap down to D. Factor, factor, factor. Okay, so are you iffy or are you good? Okay. Good. So that's going to be xy minus 1. Okay, divided by. Awesome. Uh-oh, here comes some of your nemesis. Leading coefficient. You can do this. 2 numbers that multiply out to give you 14. And when we do outer, inner of FOIL, the difference is going to give us 19. Good. So 3 times 7 is 21, so that would give us a 21x. Minus 2x is 19x. And then last, there's nothing to do here. I'm just going to rewrite it. Anybody have a question so far? Anybody? Okay, I'm going to start you off with these 2 restrictions because they're different. You haven't had to do this before. This xy, so x cannot be 0. Neither can y, because if either of them were 0, then you'd get a 0. Now, I'm going to take xy minus 1, and when I set it equal to 0 and try to solve for the variable, I would get xy cannot be 1. Do you agree with me there? Does anybody not see how I got that? Because that's different than what you guys are used to doing, and that's fair game on a test. Now, you could also see under multiple choice, instead of this, maybe they want to write that. Do you see what they did? They just divided by the x, so one variable was by itself. What would be another variation of this? You've got it. So all of these are equally correct for this. So if there was a multiple choice and you didn't see your obvious choice, look and see if they played with the value. That's what they do on SAT all the time. I took xy minus 1 equal to 0. Okay, next. What do I have to do with, like, all this and all that? Flip it. Okay, so let's do some flipping. Let's change colors so it's obvious what's what. So we have a 4x over xy times quantity, xy minus 1, times 3x minus 2, x plus 7, over your quantity x plus 2x minus 2. Flip again because there's another division sign. Okay, I need to add to my restriction. Good. So x can also not equal positive or negative 2. When we did the flip, do you see how both of those are going to land down there? Question. This is the longest of any of the problems. Chris? Why did I not? Why did I not include it in the beginning? Oh, because I forgot it. I didn't even finish all those. I didn't even make it past. I forgot a couple of them, actually. From before I flipped, thank you for noticing, x cannot be negative 7, but I forgot something else also. What else did I forget? 2/3? Thank you. Well, x cannot be 0, y cannot be 0. I grabbed that one. Okay, so finally I get to cancel because I took care of everything. So let's see what goes. X, y. Anything else? We just did all that work, nothing else goes, but you needed it for your restrictions. Your answer is what is left. When you go to put it back together again, I would write that x minus 2 with the square, so I don't have to write it twice, but you just put back together what's there, and that would be your final solution. Okay? You do need the factoring to list any restrictions that are there, so it wasn't wasted time, and no, you don't have to multiply it back together again. So as you're working on your homework, be careful with that. If you haven't gotten a survey done yet, make sure you do that. Your Chapter 8 test is after vacation, so I made sure the way I split it up that we have 2 practice days when we come back from Thanksgiving break to refresh your memory before you have your Chapter 8 test. Yes? Your Chapter 7 test isn't even graded yet. So you're going to get your graphing quiz back as soon as I can save this and walk away. So give me 1 sec.